Hi, everyone. Thank you for joining us today. My name is Leah Hines. I'm the Executive Director of the Charleston Conference, and I'd like to welcome you to our webinar, Artificial Intelligence and Scholarly Research, Part 2, AI in the Research Library Environment. I have just a couple of housekeeping announcements very quickly before we get started. This session is being recorded, and the link to the video will be sent out to all registrants within 2 days of the end of the session, so you'll get that pretty soon. We're going to be saving questions for our panelists till the end. I'll talk in just a moment about how to submit your questions. And then I would ask that you would please complete a very short attendee evaluation at the end of the session. There'll be a link provided for that. We're using Zoom for our platform today. So in case you have not used this platform before, it'll ask when you set up, when you join, to turn on your audio through your computer or through your phone, and you can choose the best option for you there. There's also an option at the bottom to raise or lower your hand, but we're not going to be using that functionality today. The one that I want you to pay attention to is this Q&A button at the bottom of your screen. If you'll click that, there'll be a window that pops up, and anytime during the presentation, if you have a question that comes to mind, you can enter your question there, hit send, and then we'll save those till the end. And our panelists will address questions, as many as they can in the time allowed. So our panelists today are Ruth Pickering, who is co-founder and COO at Yewno, and Michael Keller, University Librarian and Vice Provost for Teaching and Learning at Stanford University. Ruth is curating the newest title in our Charleston Briefing series that will be coming out soon on the same topic of the webinar, Artificial Intelligence in the Scholarly Research Environment. And Michael is going to be authoring a chapter in that title. And then today they're going to be talking about the content for that chapter. So with that, Ruth and Michael, I'm going to turn it over to you. I'm going to mute my microphone and turn off my camera, but I'll be here to answer questions in the chat if anyone needs me or has a technical question. Thank you very much.
Lovely. So firstly, thank you very much, Leah, to you, Katina, and Matthew for the invitation to write the upcoming Charleston Briefing. I've actually spent most of my career working in technology. So when I understood the audience for the briefing and what was wanted, I felt that there were people more expert than I. So a second thank you to the wider group of authors who have helped work on this project, one of whom is Mike. And today I'm delighted to be sitting here having this conversation with Mike Keller, albeit in different locations. So Mike, first of all, could you please tell us a little bit about your academic and professional background?
Yes, and thank you, Ruth and Leah, for inviting me to both be an author for the book of a chapter with my colleague, Nicole Coleman, and for inviting me to present in this webinar. A long time ago in a galaxy far, far away, I began to study science and a rather broad distribution, set of distribution requirements at a place called Hamilton College. Eventually, I majored in biology for a couple of years and then switched over to music in my senior year. So in effect, I had two majors, one in biology, and I specialized in genetics, and another in music, especially music history. Then I went to graduate studies in musicology at SUNY Buffalo, which had a very fine faculty, educated in the old and original conception of what a study in an art form would be. So not just the performance and the compositional practices that might mark a scholar, but also the physics of music, the sociology from the perspective of patrons, to the perspectives of families of non-aristocratic backgrounds whose children might become well-paid, or at least making a living at being performers or composers. All of these considerations about theory, composition, the distribution of music, through the printing of music, the compositional practices of various composers, considering Beethoven, who was a drafter, and Mozart, who had everything in his head and just wrote it out as he rode from place to place. Comparing J.S. Bach to his predecessor, Heinrich Schütz, who was older by at least a generation and yet a big influence on J.S. Bach. Through this education, a pretty broad-based one began to understand that this art form and its many, many parameters provided a kind of fabric, three-dimensional, four-dimensional fabric of ideas and relationships and practices, instrument making, money, how money made a difference, the role of kings and aristocrats, the role of famous musicians, who got to travel around and so forth. So as I learned more and more about this field of musicology, I began to be very aware of the many possibilities for research and discovery that are based on a mix of at least some of these parameters in doing my research. So as the world evolved, I began to work at SUNY Buffalo in the music library as a music librarian. And in 1970, as one of the new members of the Library Executive Committee, OCLC, then called the Ohio College Library Center, invited the 5 associated university libraries in upstate New York to participate in a shared cataloging enterprise that has continued really to this present day. And it's gone from colleges and universities and public libraries in Ohio to tens of thousands of libraries around the world, where amazing amounts of metadata are created, consumed, shared, and so forth. Through all this, I always taught who were taking my course in research and bibliography to consider the various parameters of an information object to drive their search for relevant documents, relevant testimonials, relevant archives, so that they didn't leave stones unturned if there indeed were stones to be turned. So I'm ready to go to the next question. Ruth, are you there?
Yes, lovely. Thanks, Mike. Given the broad education you received in science and musicology, what are the hopes and aspirations that you have had as a librarian that making it more apparent that many different connections within a framework of music are not well understood and therefore limit deep understanding of all the interesting possibilities for amateurs, as well as music lovers, performers, and scholars of music?
So the main threads both at Hamilton and SUNY Buffalo had to do with understanding how one might discover not just the realizations of composers and performers, but also their intentions. How can one, not merely with analysis by one's brain, lead you to deeper understandings through documentation or other interpretations by others with a different context one might have through to interpret a piece of music, whether in performance or theoretical analysis or the reception by patrons and audiences. These all were meant to help one consider possibilities either as a performer or a member of an audience or as a scholar to perceive different interpretations that had to be taken or could be taken into account. In short, the discovery of these alternative parameters of an idea, a person, an event, a place, a notion, all of these have been on my mind as I became a music librarian and instructor in musicology and then associate university librarian for collections at Yale. And now, as I am leading a large research library where we have great possibilities for innovation, many of which we have realized and many more of which we're dreaming about and beginning to work on, I see more and more interesting possibilities thanks to AI.
So Mike, how did this then lead you to be interested in AI further in terms of machine learning and neural networking?
So until I arrived at Stanford, I had relatively little contact with computer scientists in those early career appointments. However, when I arrived at Stanford, it became apparent to me that there were some new possibilities for our work in libraries and research libraries, connecting people to resources. It could be of use to them in their work, whether scholars or students or users or parents. And those resources principally were people. So in computer science then, I'm now talking about 1993, the presence of John McCarthy, a very prolific member of the first generation of scholars who worked on artificial intelligence, and Don Knuth, also in CS and still a friend and occasional advisor. McCarthy died 12 or 15 years ago. Additionally, Professor Ed Feigenbaum, a generation behind McCarthy and a major contributor to AI progress, is still a friend, still an advisor, and is deeply interested and committed to libraries. All these people, and really more, in one fashion or another, reached out to me, and we've had what I might say is a very long conversation, a lifelong conversation since my arrival back in '93. Although John McCarthy died some years back, he had some great ideas in my first years about what to do in scholarly publication and with library collections, mainly digitizing library collections and going to e-publication for scholarly contributions. This went on in earnest, of course, when Google and Larry Page and I and several others, including friends at the University of Michigan, began the Google Books Project. Although, frankly, Google has not finished the program they intended. McCarthy's main idea was that much could be done to enhance learning, understanding, and new methods of instruction using digitized resources and aspects of AI. He was a crusty character, very insistent, but also brilliant. So paying attention to him was challenging, not only in the interpersonal sense, but in the sense of the ideas that were flowing so readily from his brain to mine. Both Don and Ed have had similar influences and ideas, and they've been helpful in different ways. Both are fond of and deeply involved with libraries and my library, and they've been advisors in suggesting changes and alterations, projects that they would like to do, and in general, they've been very helpful to us. Ed Feigenbaum, has been notably helpful by working with us to create a truly interactive and highly linked personal archive online, a resource with all sorts of studies possible, not least as an example as of how a passive archive, just papers, might be transformed to one that actively supports research by modern web tools.
So Mike, how did all of this lead you to become involved with AI specifically in libraries?
Let me start this story, which I'll then have to complete as we go through these questions that you have arranged for me. In about 2007, I was recruited to be on the board of a small Swiss biotech company. Its intention was to discern possible applications of known small molecules, human peptides, in treating rare diseases. I think one of the reasons they recruited me was my involvement with Google and my appearance in a book about the beginnings of Google that named me in one of the latter chapters. So the company was essentially employing human brains, PhD level biochemical specialists in human biochemistry, and a brilliant chief scientist, also a PhD, to read articles, synthesize them in their brains, and then try to understand which articles are related to the ones that they were reading that could be of use to them in discerning the use of human peptides, really the reuse of human peptides in treating these rare diseases. About 3 years later, the company had to hire a new CEO, and I learned from him what was intended and what the role of discovery and links between human peptides and rare diseases could mean in treating people who rarely get the attention of medical experts, as there are too few patients in any one of these rare disease categories. This new CEO was an applied mathematician. He called himself, and still does, an econophysicist. And he was and is extremely capable in AI, machine learning, various advanced conceptions and techniques, such as neural networking, that could lead to different modes of discovery than we presently experience. So in a sense, the chief scientist and I stimulated this man to create a new method of making use of the multiple entries and metadata and so forth, abstracts in Medline. And he, in 15 months, created what we called a search and match service out of the 21 million Medline entries that began to make relevant hypotheses of relevance between the theories of action of peptides, human peptides, and the theories of action of rare diseases. We went from the early stages of my time in that company from about, 12 or 18 use patents issued to us by EMEA to over 300 use patents in the year plus a few after the search and match system was ready. So in addition, he provided a way of a graphic representation of these, of the corresponding trail from a human peptide to a rare disease and why the elements of the trail were relevant or possibly relevant. It was a terrific, really a terrific learning experience. I'll talk about this more later. Then about 5 years ago, Nicole Coleman, the digital research architect in the Stanford libraries, who had been an academic technology specialist, began talking about how AI could be helpful in library operations. She spoke to people in CS and the other departments, including linguistics, about her ideas, and gradually I became aware of them And we together began to think of how AI could be helpful to us. All this thanks to Nicole's thought process and stimulation. I'm going to talk about a little bit more about that later, since what's happened.
Thanks very much, Mike. So diving more deeply into artificial intelligence, can I ask you, first of all, how you would define artificial intelligence, and also if your definition is influenced by your special focus as a library leader?
So certainly what I'm about to tell you is the result of thought processes and experiences as a library leader in a place where innovation is valued and supported. And frankly, one of the assets, in addition to the people that I mentioned earlier, has been the freedom to innovate, actually the demand to innovate. So what is AI? It has a lot of different definitions, depends on who you listen to. But for me, AI refers to machines that have the capacity to solve certain kinds of problems. In a way, machines that learn on the basis of what information they can ingest and what programs have been written for them to ingest them, and how their clients, those who receive this information through an AI machine, react to what the results are, and then in turn improve the performance of the artificial intelligence, the machine that thinks. So these machines involve heuristic, and they have several different iterations in any engagement with data, numbers, text, images, to solve problems, to address concerns, to identify and match patterns, and so on. Through all this, and with brilliant means of training these machines, can come some benefit to libraries. AI literally refers to machines that can think in certain ways, and maybe even to learn by our interactions with it and its products. Certainly that's the case in the brilliant example provided by this econophysicist. Why is this relevant to libraries? We're in the knowledge and management field. We have an enormous pile of academic information, monographs, articles, social scientific data, government data, image collections, archives, some of which we've been digitizing so they're more readily available to more people in more places. And also an enormous pile of digital books and digital articles brought up in the last, I would say, 20 plus years, 25 years. All of these digital objects are highly relevant, but they're highly difficult to navigate through. The big challenge that we have arises from our use and dependence on metadata, i.e. assigned information to those genres and formats that are intended to make the original sources discoverable to those who might make use of them. But metadata is a pale reflection of what the contents of any of these knowledge objects, information objects are or could be. So AI offers better opportunities to understand a known object, not just by keywords and key phrases, or assign topics from a fixed, and I would say old collection of subject headings, such as the Library of Congress subject headings, and really biased information sources too. AI is one of those very powerful tools that we can use to improve the discovery of relevant text, hypothetically relevant text, images, data, to the work of the researchers and instructors at our institutions of higher education and who perform research.
Thanks, Mike. So search and discovery have long been two of the most important research activities that libraries support, although Google and Google Scholar have definitely moved in on our territory. Can you talk to us a little bit about those two companies and the type of search that they offer?
So actually Google and Google Scholar are the same company, but I'll talk about them as two different services. Let me start off by saying we've had a terrific working relationship with Google and still do. They spider us every week and they pick up our metadata records and other information out of the library website here at Stanford, which then becomes part of their great assemblage of metadata and full text data really to provide readers searching on Google, the classic Google, for information. And we were delighted and still are delighted to have been among the first to help them digitize many of the books in our collection. They've only done about 3.5 million. I wanted them to do almost 10 million, but so far that hasn't worked out so very well. The Google search service must be based on huge number of web pages and digital information sources. And in many ways, it's terribly impressive. But the number of sources is gigantic, and the way they massage those sources, understand them, use AI to understand them, use linked data to understand them, and then present to inquirers, users. It's enormously useful. And many of our students begin their searching at classic Google, although they eventually come home to us and they generally stay with us. It's also an advertising agency, that's Google. And in many ways, this is quite complementary to what we're trying to do at Stanford. We know that the undergraduates go to Google, they use keywords, they get matched, they maybe get a few hundred resources, and then they search through those and find their way through this enormous thicket of possibilities. Google Scholar is a much different service. From the early 2000s, Anurag Acharya, the man who leads that and is an absolutely brilliant guy and a very good friend, took the articles that were being brought to the web by publishers through Highwire Press and eventually has harvested what I believe to weigh well in excess of 3 billion articles. Anurag will never tell me how many articles and ebooks he's got in that great service, but I suspect it's a very big number, and it's all academic. It really is scholarly. And it's you search it using keywords and key phrases, which in English makes a lot of sense because English is the language, particularly of STEM disciplines, and to considerable extent many other disciplines as well. But that's a limitation. Google Scholar has another limitation, however. If you enter a few keywords and key phrases, you may get enormous results, more than 1 million results. And then you have this challenge of limiting the results till you get to articles that may or may not be relevant. One of the ways is to know a lot about the topic about which you were searching. You would add more keywords, you would add more phrases, and you would then generally reduce the number of hits to something more manageable. It might go from 1 million to 500,000 to 50,000 to 5,000 to 500, and maybe if you really know the topic well and you're really acquainted with everything in the field, you would get down to 50, which is a reasonable number of articles or ebooks to begin to try to comprehend. The other way that they provide to limit these results, to filter these results, is to look at them by time frame. So let's say you're a scholar who at the completion of the spring semester goes off somewhere for 3 months of rest and relaxation, doesn't read the journals, doesn't keep abreast of the new books that are being published. You come back, you do a search on your keywords and key phrases, and you get 1 million results. Google Scholar provides a way of limiting those results by their date of publication or date of release. So you could have a 3-month clump to go through rather than 1 million. And there are 2 other possible limiters, both by date. So the big deal here is that one has to filter these results by knowing a lot about the topic to begin with. It's not a very good place to begin to search for interesting articles, relevant articles. So there's a challenge there. And to be frank with you, I think it's not a very good investment of time if you don't know a lot about a topic to start with Google Scholar.
Thanks, Mike. So how would you describe the difference between traditional keyword or phrase searching and AI-driven systems that search by concept? And could you tell us a little bit about why the difference is significant?
So as I've said, reliance on one's sense of what words might occur in relevant knowledge objects, information objects, you are limiting yourself to your vocabulary and maybe your knowledge of the vocabulary of your field if you're in that field in a reasonably deep way. But there's so much more in these articles that may be expressed differently than the way you're doing your search, or there may be more ideas in the article that you don't know about, but might be relevant to your interests, that you can't get to because you don't know the precise way those notions, those concepts are expressed. As a matter of fact, our brain doesn't store full texts. Our brain stores ideas. We are the classic example of neural networks. Our brains store ideas, images, pictures, time sense, but they don't store full text. Well, there are some people who can do that, but they're very rare on the ground. So we have a difficulty because our information systems, the ones that we have built, we humans and we librarians have built over the centuries and recently over the last century in particular, that don't operate like a neural network. They don't operate like our brain. There's been a lot of science fiction on the subject, and the one that I think is perhaps the most foresightful in a way is Gordon Dixon's work, The Final Encyclopedia. It's a 2-volume work, and it refers to what must be a neural networking satellite roaming around the heavens somewhere with a monastic-like crew who can yield information on demand for leaders and so forth, of all the information that humankind has ever had of any kind. So the question is, what's authentic then? And that is an exercise of judgment. And presumably these monastic folks have had that judgment taught to them and learned from questions provided by those who need information. It's a wonderful book. It's a kind of, they're referring to a kind of living thing, this huge neural network of ideas in this satellite circling somewhere in the heavens. So we need to think as a species and as individuals in our social settings, in our communities, about whether there's a better way to find information that's relevant to our needs, all kinds of needs, than literality, the literal expression of ideas. And we need to work, in my view, across genres, but also across languages and cultural contexts, and across perceptions and ways of thinking. And of course, the ideas are not generated and expressed and thought of in the same ways across cultures. It takes a great deal of understanding and really phenomenal multilingual talents to understand why these differences exist and how to make use of them. So keywords and key phrases are not the way, it seems to me. They're part of the way, but not the way. I think what's much more interesting is the collection of knowledge and knowledge objects that are based on ideas coming down through the use of AI to relevant texts and relevant collections of ideas, which concepts are not based on literal sentences and paragraphs, but are otherwise semantically driven and are digital. So the big deal is make use of concepts, which can be done using AI, neural networking, machine learning, interaction with human brains and artificial intelligence brains, etc., to produce more and better ideas of relevant documents and really relevant information hypotheses, both for novices and people that are deeply involved in whatever their discipline is, but maybe looking at another discipline.
Great. Thank you very much, Mike. So looking at libraries, so libraries have traditionally used metadata to enable discovery of items in their collections. Could you explain a little bit further how machine learning can allow us to search collections of data and text without using metadata?
So if you'll excuse me, I'm going to add artificial intelligence to machine learning and maybe neural networking too. It's sort of a package of ideas and functions there. So what do we do now? We have specific library-oriented specifications that enable us to create descriptions of books and descriptions of articles, and we can characterize them using these various subject schemes that are abounding here and there. But there's really much more in these texts that could be used for discovery, and for discovery in a way that's relevant to an end user's need. Names, places, dates, concepts, all these and many, many more are buried in the full text. So whereas I think we do need metadata to pin down an exact, authentic, authorized text, we also could use and should use AI to make it possible for us first to derive that metadata from the text itself. So we'll no longer be creating metadata as we do now, which is good for efficiency and discovery. And we'll be able to use this enormous quantity of digital bibliographic information and commentary and really the interaction with the systems, the AI systems and machine learning and so forth by end users to create better and better pathways to the relevant source materials that we are responsible for taking and curating. So I can see us making use of AI for entity extraction to begin with, and of course, for extracting concepts as semantic expressions, not as literal expressions in one language or another, to connect these ideas and these entities to other relevant possibilities out there in the world. So the key to this new synthesis of human minds, machine minds, and massive use of data will be the use of linked data in academic bibliographic databases with a reconciliation to other sorts of representations in non-academic domains, thus broadening the possibilities for possibly relevant information and knowledge. So you see, I'm talking about two different schemes here. One is the use of AI to create metadata and to more deeply understand the concepts in an information object. And the other is the use perhaps of linked data to provide us with more, I would say, galaxies of information by relevance to ideas, by relevance to entities, and so forth. That's a big, complicated idea there, and I will tell you, nobody's working on it right now. Just a thought.
So Mike, could you tell us a little bit more about how you see the relationship between linked data and AI, and do you see these as complementary or mutually exclusive?
So I think the first time I saw an AI-based knowledge graph was in 2011, which is the year we had our first conference, multi-institution conference about linked data at Stanford. Linked data itself is focused on the linkage of entities, focusing mainly on people and works through the use of identifiers. Identifiers that are semantically active, they're digitally active. The linkage is brittle, however, because of the same identifier is not used for the same entity, the multiple versions of that linkage will not work. There are also predefined entities. The identifier is created to represent one and only one entity, but in many ways, there are many definitions of an entity and many interpretations of how the linked data should be applied, the RDF should be applied. In many ways, they serve the same function as the controlled access points used in traditional cataloging, but each parameter is paired with at least one web-based definition, a uniform resource identifier, so that the parameters potentially become semantically interoperable, which when operating with billions or trillions of such parameters, known as resource description frameworks, become a sort of multi-dimensional grid of parameters analogous to a neural network. And by multi-dimensional grid, I mean something with way more than trillions of these entries and these links. In contrast, much AI technology is designed to work with full text and focuses on automated concept extraction from full text. There are no predefined topics, perhaps. The concepts generated are based on the content of the full text analyzed. With its focus on concepts and automated analysis of text, the use of AI is a perfect complement to the more manual processes of entity creation and linking.
Thank you very much. So let's kind of whiz to the current day. And recently we've all been forced rapidly into remote working, and technology changes and adoption that could have taken years has been achieved in weeks. Can I ask what you've done with artificial intelligence to support these changes?
Well, interestingly, let's see, this is 2020. In 2017, we began thinking about how we might find some institutional partners in working on AI. We had some indicators that there were some libraries out there who were already involved or interested in being involved. So we began our multi-institution engagement with AI in libraries by co-sponsoring the Fantastic Futures Conference with our colleagues from the National Library of Norway in Oslo in December 2018. We had 350 people attend that conference, and we had more like 500 people watching the conference from afar. It was big. We then had, with our colleagues from the National Library of Norway, with whom we started cooperating in a more deep way, devise a conference at Stanford in December 2019 with 250 people physically present and several hundred participating remotely. And I must say, in both of these, Nicole Coleman, Tom Kramer, and others were really instrumental in making this happen with our colleagues from Norway. As a result of the success of these conferences, we have invited our colleagues from the Bibliothèque Nationale de France to create a consortium of institutions promoting and sharing information about the use of AI and related technologies in libraries. This consortium has grown to include the Smithsonian Institution and the British Library. We expect, we hope, that we will have, when COVID is less of a threat, conferences in Paris and in other metropolitan areas of the world on an annual basis with wide support from existing and other institutions who will join us, much as has happened with the International Image Interoperability Framework. So we at these conferences are showing actual implementations of AI in libraries, and we're hearing about theoretical applications and the role of AI in society as well as in the library context. Additionally, at the outset of this coronavirus sheltering, which happened in early March here, we offered a course to our staff who was operating remotely from their homes, but operating a course in the elements of AI, with the expectation that they will be more actively engaged in AI and related technologies in the not too distant future. Well, 40 people completed that course. We now anticipate the use of AI in our business practices as well, but clearly from the perspective, my perspective as a leader of a big research library and really an important university in terms of research output, the use of AI to support data science, which is happening all over the place here in the research community, social trends, economics, the course of this nasty disease and so forth is really important. And thus, in order to be of service to these researchers, we need to be more involved with AI and its possibilities. And we are getting more involved as we go along in time. And I need more of my staff and more of my colleagues around the country, around the world, to be more engaged with AI as well. We need a lot of brains working on this, and we need a lot of experimentation to happen.
Thanks, Mike. So when I tell people that I work in artificial intelligence and specifically in knowledge graph technology, a lot of people tell me that they're visual learners. How do you think that the visualization offered by AI-based knowledge graphs can help researchers?
So let me contrast the output of a search, a literal search by keywords and key phrases in Google Scholar and so many, many others of our tools, including our online catalogs, with the lists that come out, and then with filtering mechanisms, some of them quite efficient, but somewhat tedious and maybe somewhat limiting as well, to what happens when you have an artificial intelligence-based system, which includes machine learning and neural networking and all kinds of other inputs, including natural language processing, many, many different languages, semantic expressions that are not in language but are in bits and bytes. You end up possibly with a knowledge graph that makes it clear by reference to ideas, to concepts, the relationships between nodes of knowledge in the resulting knowledge graph. And of course, one can't put all of the related concepts in a knowledge graph. There's simply not enough space in the world, and we don't have hologram projectors and screens and so forth. So one has to engage in some filtering and even adding some concepts to come to a smaller set of concepts that then one could focus on. The good thing about a knowledge graph is if you just start with your idea, you will see generated in front of you many other related ideas with related concepts that you can select and then operate on. And ultimately you'll get directed, I think, in this one case, Yewno, to documents that contain the concept. So you get indicators of possibly relevant documents and indicators of possibly relevant concepts that you can examine rather quickly and easily. So this scheme, this visualization of knowledge, I think is huge. And right now we're looking at 2D knowledge graphs, but in my head are 3D. And somehow I think we could even have 4D representations of knowledge in very expansive graphs. I think that's possible. I think it's going to take a lot of development. And we in the knowledge management business, helping others learn how to take advantage of these advanced techniques, need to be au courant and very skilled with them ourselves. And we need those knowledge machines, the AI, the huge text bases, the image bases, and so forth, neural networking, to be very large. They need to be very large. They need to be the size of Google Scholar if it's possible, so that we have a huge representation of ideas in the academic sense. I don't think we need to cover entertainment too much, or maybe somebody else can do that, but we need to be looking at many, many nodes of representation of ideas in these knowledge graphs. That said, I think once we begin to train students to make use of knowledge graphs, to understand how ideas are related, and really to begin to understand how their own brains work, we're going to be in a better place, a much better place. It will be a stimulus to the imagination, and it will lead us and lead our users to better ideas and maybe better research, simply because there'll be hypotheses of relevance that become more accessible in more ways, more easily.
Thanks, Mike. So for the Stanford community, you and the library team have created a very beautiful website, which offers a range of different search options. Can you explain to us a little bit about the different search options that you offer and how you expose those on the library site, and what the reactions are from different members of the community to the options that they can see there?
You bet. So on the Stanford Library website, I invite you all to go there, library.stanford.edu. You'll see in the opening page, after some announcements about the COVID e-resources that we've made available, you'll see an empty search box, and you can put any words and phrases in there you like, and click on the little magnifying glass image, and a federated search will be sent out. It will go to four different services in a kind of bento box array. The first will be to our OPAC. And we have a pretty big collection, and we get lots of results for some kinds of searches. But thanks to Tom Kramer and his team's use of blacklight, we have a fantastic set, maybe a dozen filters that enable an end user to quickly isolate by date, by author, by genre, by library, by topic, isolate a much smaller set than one might originally have discovered through the use of one or several keywords or key phrases. We also take that original expression and apply it to the bibliographic database that we license from EBSCO. We run it through our blacklight interface. I think the EBSCO database is, well over 1.5 billion entries. It's big. It's really big. And we get huge numbers of results. And we similarly have these blacklight filters that enable a result to be brought down to a reasonable level, all based on keywords and key phrases, original search, and the addition of these topics and authors and so forth. It's quite remarkable. You can all make use of it. If you do not have a Stanford ID, you won't be linked to the relevant articles or to the relevant ebooks, but you can at least see it working. So the third element is a search of our rather large collection of web pages in the Stanford Library, with a great many of our digital exhibits and our many digital services, including online music, riverwalkjazz.stanford.edu, for instance. And one will get results that are pertinent based on, once again, on keywords and key phrases. And finally, there's a widget that takes the original expressions, matches them to a concept, and you click on that central concept in this widget, and you're taken to Yewno for the full Yewno treatment involving graph knowledge graphs appearing, and then the kinds of interactions and manipulations of the knowledge graphs that lead to rather specific findings on the one hand, or rather interesting explorations and discoveries as a result of the knowledge graph application. So we have experiences in all of those. We have a lot of people from around the world who use our OPAC. We have some who make use of this Article Plus file that we have, and many make use of our online exhibits and our digital assets and the services that we provide free, really, to people who are interested. And people can see the Yewno widget, but they can't go there unless they are Stanford people. That's a license thing. So our experience is a lot of students make use of the OPAC, particularly after coming to us from Google. A lot of people at Stanford make use of the Article Plus file, which is all kinds of articles, both and traditional, books and traditional books, and etc. To be frank with you, our website is much smaller than Google and doesn't cover anywhere like the waterfront that Yewno covers. So people use it, but typically they're interested in a particular exhibit or a particular service that we provide. With regard to the students and the faculty's reception to Yewno, we get a lot of praise, particularly from the students who are introduced to it in the introductory freshman and sophomore courses, which are required courses. And they learn because they've never been taught really how to think about efficient searching, most of them, how to think about a search, how to discover and explore what's available to them, not just at Stanford, no, but across the world, across the universe, galaxy of all these possibilities. But principal among the services that they really latch onto is this knowledge graph approach. And we're wondering how we can apply it more broadly.
Thank you very much, Mike. So we've covered a lot of ground, and before I open out to questions, I wonder if I can ask you if you could sort of re-summarize what you think the biggest opportunity is that AI can offer to the library world.
Well, it's not just one, I think it's several. The first is the use of AI to promote and more deeper discovery based on various aspects. Sometimes extraction of entities and use of those entities in our more traditional bibliographic files, supplanting really, I think, in real terms and soon, the MARC record approach. I think making that discovery based on this entity extraction and then repurposing of the entities that extracted is a very interesting proposition. And indeed, we subscribe to the Nielsen book data to supplement the bibliographic data in MARC records for maybe we're over 500,000 of them, I'm pretty sure, over the last few years, that provide more words to search on. But once again, it's keywords and key phrase searching. Secondly, I think it's very important for people to understand that there are these systems, very complicated systems, that extract concepts multilingually. That is to say, there's the possibility of understanding from many different linguistic fronts or cultural fronts, ideas that grow up from a culture, ideas that grow up from science, that grow up from art, grow up from social conditions and so forth, that will make much more interesting and really much more relevant many different kinds of research that otherwise would simply be languishing. I think AI has that possibility because of its ability to understand ideas, to extract ideas and present them as possibly relevant hypotheses of continued work, continued reading, continued invention, continued analysis, and really continued reporting as well. Those are the two main ones. We also have some possibilities, I think, in using AI in business transactions and understanding what our readers are reading and using and quoting and citing. But they, in a way, are secondary, and they're sort of derivative from existing systems that don't cover the waterfront, but at least we have examples of how they work.
Fantastic. So Mike, thank you very much for joining us here today. And I appreciate your answering such a broad range of questions. So we've covered most of the things that have been emailed in. So at this time, I'm going to hand back to Leah to close off the webinar. And if anyone does have further questions, please feel free to write in.
Well, thank you very much, Ruth and Mike, for a fascinating conversation. And thanks to all of our participants who tuned in. I'll give everybody just a few more minutes if there's another question that might want to trickle in. And in the meantime, I will remind everyone that this is part 2 in a series, and part 3 will be coming up on June 17th. So please do tune in for that. I'll be sending out registration details. It'll be on the Charleston Conference website and be emailed out to everyone who registered for this session. So with that, I guess I will turn things off here. Please do, there's going to be a very short 3-question evaluation. The screen will redirect to the link for that survey when things close here. And contact me if you have any questions. Thank you very much for tuning in, and we'll hope you'll be here next time for part 3. Thanks a lot, everyone.
Thank you.
Bye.